When writing scripts, we can ask questions about the player's actions and the game state. After receiving answers, we can decide upon them. To compose questions, Unity's visual scripting offers us a handful of logic nodes. Each node provides a single output, a boolean. Let's say our game features a car. We can ask whether it has gas. Do we have its key? Is it broken? Etc. The building blocks for asking questions are comparing one thing to another. The fundamental comparison type is asking whether one thing is the same as another. In a car, if the remaining amount of gas in the tank is equal to 0 gallons, we are out of gas. Therefore, the car cannot drive. In a graph script, we have the equal and not equal nodes. Each receives two values and answer if they are the same. Those nodes accept any data type, including numbers, strings, booleans, vectors, and others. When we have two numbers, we can compare their values and ask whether one is greater than, or maybe less than, the other. If the car speed is above 55 miles per hour, we are exceeding the speed limit. In a script, we can use the greater and less nodes to compare numbers. We have the greater or equal node to ask if a value is at least some value, and the less or equal node to ask if a value is at most some value. If you want to ask multiple questions upon the same values, we can use the comparison node, which answers all the questions at once. Now that we have the basic building blocks, we can combine them into more complex questions. If a character owns a car and has a key, it can drive the car. We use the AND node to combine two questions, concluding if the answer to both is true. If a car is out of gas, or has a malfunction, it cannot continue driving. We can use the OR node to ask if either of the answers is true. One thing to note is that when we say either question is true, we don't mean that only one can be true. If we do want to limit to only one of the questions to be true, we have another node to accomplish it. Even if two characters own keys to the same car, it can only have one driver at once. We use the exclusive OR node to ask whether one and only one of the questions is true. We use the negate node to convert a positive boolean into a negative and vice versa. For example, the not equal node is just a shortcut for negating the equal node. We can combine multiple questions to ask even more complex questions. In fact, the exclusive OR node is an example of composing two questions. Now that we know how to ask questions and compose them into more complex queries, we can move on to make decisions based on the answers. The control flow nodes, together with the logic nodes, are the art of coding. They are used for decision making, guiding a script graph on dynamically executing gameplay based on the game's current state. When we speak about control flow in visual scripting, we refer to how our scripts are executed, when different actions are performed and in what order. We previously got to know data types, and that nodes have inputs and outputs of data values. We also briefly mentioned that nodes feature green arrows. Each arrow is a flow. When we connect an output flow to an input flow, we tell the script graph that after performing a node, it should move on and perform the connected node. We now know the two types of connections in our script graph: the control flow of execution order and the data flow of passing values around. The two flows are not dependent. A node can be used without the control flow. We can also pass the data flow to one node and the control flow to another node. We previously learned how events are the starting points of script graphs. Therefore, they feature only an output flow. They allow us to react to the player's actions, and in a few moments, we will see how we can utilize the control flow nodes to update our response to the player's actions dynamically, while taking the game state into account. But first, let's ask, when do we need dynamic decision making in our scripts? Let's say we want our character to unlock a door with a key. We only want the door to open when the character is holding the key. In this scenario, we have a condition, and we want to behave differently depending on the condition state. If the character lacks a key, the condition is not fulfilled. Otherwise, the condition is met. Let's see how we can implement this in a script. The if node uses a Boolean condition to determine which of the two output flows to execute. When the condition is true, it will do something. Otherwise, it will do something else. This node has two inputs, a flow and a Boolean. It also has two flow outputs. This may be the first node you encounter that consists of more than one output flow. The control flow will continue to only one of the branches. According to the input condition, the node chooses a branch, one branch for a true value and another for a false value. Speaking of if you enjoyed this video, please hit the like button. The switch node is similar to the if node, but uses a value input instead of a Boolean condition. As a result, this node can have more than just two branches of flow outputs. When we select a switch node, we can add, edit, and remove options in the graph inspector. Each option we add will create an additional output flow for the node. This switch node has a default flow output. It is used when the input value doesn't match any given option. The switch nodes come in three data type flavors: integer, string, and enum. We saw how switch nodes translate a value into one of the multiple flow branches. A select node, in contrast, maps such values into other data values instead of flows. Let's say we have a Boolean. We can map it to 5 when it's true and 8 when it's false. A more advanced example will use select on integer. In the graph inspector, we can add a few options, say -2, 4, and 12. In the graph, we can then connect a different vector tree to each option. So now, when we pass one of the configured integer options, the node will provide us with a matching vector tree. It's essential always to provide input to the default port. In addition to Boolean and integer inputs, there are also select versions for flow, string, and enum. Like a light switch that can turn a light on and off, we can use the toggle flow node to execute different branches, depending on whether the toggle is on or off. The on and off output flow will execute based on the current state. We can connect flows into the on and off inputs to change the state, or into the toggle input to flip it. Immediately after we switch a toggle, it will perform the turned on or off flows. And in any given point, we can determine the current state through the is-on output. Another form is the toggle value node. It's similar to the toggle flow in a sense that it has an on and off switch. Yet, instead of executing different flow branches, it will determine the output value based on the input on and off values provided. When the toggle is turned off, the output value will be whatever is connected to the off input and vice versa. When we use the onUpdate event node as our starting point, the flow will execute each and every frame. We can use the once node to limit a portion of the flow to run only one time, ignoring subsequent executions of the script. Using the after output, we can differentiate between the first and subsequent actions. Last, we can use the reset input flow to return the once flow. The last node is sequence. It will branch out the execution to multiple flows and perform them in order. It can be used for better organization and reliability by splitting a long flow. For a more advanced example, our first branch in the sequence can be interrupted and stop performing based on an if node. We can add another branch that will perform whether or not the first branch is executed entirely.